Hello dear students, myself Ganga Bhosle, your statistics teacher. Today we are going to learn standard normal distribution. The equation of, we know the equation of normal distribution with mean m and standard deviation sigma, which is given by y, which is equal to f of x, which is equal to 1 upon sigma into under root 2 pi into e raised to minus 1 by 2 into x minus m divided by sigma bracket square, where x lies between minus infinity to plus infinity. That is, this y follows normal distribution with parameters m and sigma. Then when their parameters m and sigma represent the complete distribution and the area under the normal curve. For finding probabilities and simplicity, we can transfer the different distribution for different values. Here, values of m and sigma into single one, and this is our standard normal distribution. That is, for different values of m and sigma, we have find out the different probabilities and distributions. That is, for when we shifted m, that is mean, by origin and reducing scale by sigma, here we get z is equal to x minus m divided by sigma. Then this equation becomes f of z is equal to 1 upon under root 2 pi into e raised to minus 1 by 2 into z square, that is x minus m divided by sigma. This is represented by z. So here in this formula we get z square. Minus infinity is less than z is less than infinity. That is, z lies between minus infinity to plus infinity. That is, z follows normal distribution with parameters 0, 1. That is, m is equal to 0 and the value of sigma is 1. This is our standard normal distribution. This equation is our standard normal distribution, and this standard normal distribution is represented as S dot n dot v, that is standard normal variable. This is our v, that is variable, and for standard normal distribution there is S dot n dot d, okay, whose mean is 0 and variance is 1. That is, m is equal to 0 and sigma is 1. Now, properties of standard normal distribution. The mean of standard normal distribution or variance, that is z, is 0. That is, E of z, which is equal to 0. The variance of standard normal distribution, z is 1. That is, V of z is equal to 1, and standard deviation, that is under root 1, which is equal to 1. The standard normal curve is symmetric about the line z is equal to 0. This is our normal distribution bell curve, and here minus infinity less than z is less than infinity is 1. Then p of minus infinity less than z less than or equal to 0 is equal to p of z less than or equal to 0, which is equal to 0.5, and for p of 0 less than or equal to z less than infinity, so here it becomes p of z greater than or equal to 0, that is 0.5. Okay. Now, after this we see example 1. For the standard normal distribution z, find the probability, just a minute, here expected frequency is missing. expected frequency. The expected frequency of x within certain limits, say a less than or equal to x less than or equal to b, when the experiment is carried out of n times, this is given by n dot p, where p is the probability of x in these limits. That is, expected frequency is equal to capital N dot p, where x lies between a and b. Okay. Example 1. For the standard normal distribution z, find the probability that z lies between first 0 and 1.25, second minus 1.25 and 0, third 0.93 and 1.45, fourth minus 1.58 and minus 0.34, and last one is minus 2.18 and 1.35. Here, for calculating various probabilities, that is area, we have to refer Z table. For area under the normal curve compounding to given value of Z and find out respective values. First, here I am writing to calculate to solve this first. Okay, first one is to obtain the area between first one is, here we have to find out the area between 0 and 1.25, 0 and 1.25. So here we have to find out 0 less than or equal to z less than or equal to 1.25. Okay. This is our z table, and here we have to find out probability, that is z lies between 0 to 1.25. First we find out the value 1.25 in z table. Okay, 1.25, that is 1.2 plus 0.05. First find out 1.2. Here is our 1.2, and then find out 0.05, 0.05, then 1.2 up to 0.05, that is from this. This is our value of z for 1.25, that is probability 0 less than or equal to z less than or equal to 1.25, which is equal to 0.3944. Then this we represented by curve, that is graph. This is our x-axis. This is our center, that is z is equal to 0, that is our mean. Then here value of z is between 0 to 1.25. Then this is our 1, this is our 2. Then this is 1.50, that is from 1 to 1.50, this is 1.25. 1.25. That is, we have to find out area between this 0 to 1.25. First, we draw a bell-shaped curve, that is, just a minute. Okay, like this. This is our center, that is z is equal to 0. Then this is our 1.25. 1.25, and this area represent z lies between 0 to 1.25. This area is 0 to 1.25, and this is nothing but our 0.3944. This is our z is equal to 1.25, and this area represent z between 0 to 1.25, and this area is 0.3944, and the area between minus 1.25 to 0, that is this one. Here is our minus 1.25, that is this is 0.20 is same as the area between 0 to 1.25. 0 to 1.25, that is P of minus 1.25 is less than or equal to z is less than or equal to 0, which is equal to P of 0 less than or equal to z less than or equal to 1.25. This is, that is 0.3944. Okay. But in this equation, we have to just find out the area between 0 to 1.25. This is just extra information for you. Okay. Okay. Now we find out the area Z lies between 2nd to 5th in next example. Okay. Thank you.